Frameworks for collaborating humans and AIs, sequence and sociality in organizational applications. This is joint work with Justin Weisz, who recently returned from parental leave with his baby daughter. I speak from the traditional, unceded, and contemporary lands of the Wampanoag and Massachusetts peoples to the CHIWORK meeting on the lands of the Wabanaki and Pawtucket peoples. I honor all of the Indigenous elders and ancestors, past, present, and future. We've scrunched our paper down to the core ideas. We'll review the problems of thinking about human-AI collaboration. We'll discuss 4 examples, then we'll summarize some themes. Broadly speaking, we want to address questions about the present and future of work when human work intersects with AI systems, services, and technologies. So we look briefly at the past of work on our way to the future of work. 70 years ago, Fitz proposed, in the sexist language of the time, that men were better at some tasks and computers were better at other tasks. He proposed an allocation of certain tasks to humans and certain tasks to technologies. Sheridan and Verplanck updated Fitz's ideas, acknowledging that the allocation of tasks would probably change over time. Parasuraman and colleagues restated this concept as a dimensional analysis, as shown here. However, all of these frameworks assumed a zero-sum concept of initiative. More initiative for the computer meant less initiative for the human, and vice versa. 2 years ago, Ben Schneiderman revised this zero-sum way of thinking with his reliable, safe, and trustworthy framework for AI products. He explicitly decoupled human initiative from computer initiative, where Parasuraman and predecessors had assumed a one-dimensional trade-off analysis. Schneiderman proposed 2 independent dimensions. Schneiderman showed that many familiar technologies and products could be located in his new 2-dimensional space. For organizational computing, we initially built on Schneiderman's analysis. We located many organizational, governmental, or enterprise AI products and services in Schneiderman's 2-dimensional space. But we encountered some surprises, which led to this talk. First, we realized that Parasuraman's zero-sum trade-off dimension would fit neatly within Schneiderman's 2-dimensional space. We call this an emergent dimension because we are adding to Schneiderman's analysis. Then we realized that there could be a second emergent dimension that was orthogonal to the Parasuraman trade-off dimension. Along this collaboration dimension, human initiative and AI initiative are roughly matched. Their collaboration could be minor and diffuse, as in the lower left corner, or major and intense, as in the upper right corner. And so that's our analytic space, Schneiderman's framework plus our 2 emergent dimensions. When we began to apply this framework to understand complex AI applications, we encountered more surprises. We consider 4 examples in this talk. In the paper, we list additional applications that we've analyzed in similar ways. First, we consider the case of vandalism in Wikipedia. Wikipedia editors cannot monitor all pages for vandalism, so they made a software robot, a bot called Huggle, to examine pages for possible vandalism. When we analyzed how this bot is used, we found that it did not really fit into a single location in the Schneiderman space. The action begins with a human, a Wikipedia editor, starting the bot. That's high human initiative in the upper left corner. As the bot begins to work, the human fades into the background and the bot runs autonomously in the lower right corner. If the bot finds possible vandalism, then the bot and the human collaborate to determine what happened. Under human guidance, the bot can restore the vandalized content. The lesson here is that complex applications are not located at a single point in the 2-dimensional space. The degree of initiative shifts dynamically from moment to moment, from step to step. The next case is active learning of labels or annotations of ground truth, as it is called, in supervised machine learning. Ground truth or outcome values must often be added to every record in a large data set, which is a labor-intensive process. Active learning is a way to do partial automation. The human begins to write labels onto data records. Later, the AI learns the human's labels and begins to create its own labels much more quickly on additional data records. Of course, there are cases where the AI has low confidence in its labels, and so it can ask a human to inspect those particular labels. The AI learns from corrections that the human makes. Again, the lesson is that active learning does not take place at a single location in the two-dimensional space. The third example is the use of voice recognition technologies for a now vanished job role, that of directory assistance telephone operators, in which an employee of a telephone company would look up a phone number in response to a customer's spoken inquiry. As we showed in an earlier paper, the operator's work was strictly constrained by the support technologies. It's a kind of workflow. The workflow moves across 3 of the 4 quadrants of the two-dimensional analysis, depending upon whether the human or AI is in control at each step. Again, we see dynamic shifts in initiative from human to computer and back again. This example also shows that for some AI applications, there's more than one person involved. In the language of value-sensitive design, we would call the telephone operator the direct stakeholder because that person interacts with the AI and other components. The customer is an indirect stakeholder because they need the operator to provide the information. The AI technology affects both stakeholders, but in different ways. The last example takes the multi-stakeholder analysis further. When a customer applies for a bank loan, the loan officer uses an AI-based system to determine whether or not to approve the loan. A simple way to look at this application is that the customer initiates the process by applying for a loan in step 1, which is a high human initiative activity. In step 2, the bank officer consults the AI, and the AI has nearly all of the initiative. The algorithm decides whether or not to allow the loan. By step 3, when the loan officer tells the outcome to the customer, the humans have very little initiative or power. However, the algorithm is, of course, made by humans. The two-dimensional analysis allows us to ask feminist who questions. If the loan officer is required to follow the AI's recommendation, then who are the humans who determine the AI algorithm? The answer turns out to be complicated, because data scientists probably made the algorithm, but a bank engineer probably parameterized the algorithm for this particular bank. And both the data scientist and the bank engineer were following instructions from their respective executives. Of course, none of these people, the data scientists, the engineers, or the executives, are available during the loan application process. The customer and the loan officer are locked inside decisions that were predetermined by invisible others. We've shown that present and future computer AI applications are not located at a single point in the two-dimensional space. Rather, the degree of human initiative and AI initiative changes dynamically from one step to the next. And many of the organizational applications require intense collaboration among humans and AI. We've also shown that many of these systems involve multiple humans in different roles, and we've begun to explore how a critical HCI analytic approach can clarify power relationships that may involve hidden roles and invisible decision makers. Most of the prior analytic work has taken place at the level of a product's location in Schneiderman's space or an organization's priorities for a complex sequence of actions. By asking the feminist and value-sensitive design questions in multi-human applications, we can move toward a more balanced, human-centered data science analysis that can include workers' perspectives. In a US National Academy of Sciences report this year, Schneiderman wrote that in successful AI systems, people can choose how much automated help they want. However, workers have to labor within the work worlds that technologies have made, that technologists have made, that we have made. Organizations design workflows in part to limit human actions, permitting only those actions that the organization wants them to do. The AI algorithm becomes a projection of power by its designers, the scientists, the engineers, and the executives, and that power is executed upon the workforce. And so we return once more to the feminist technological analyses. Technologies do not come ex nihilo from nowhere. The who questions still matter. We end with some of those who questions, which we think have importance for the future of work. Who designs the work? Who implements the design into technologies? Whose work is controlled by those technologies? And what is our role in forming and especially reforming those control structures? Thank you.